All right. So it's been like a week. What?
Vitamin C.
You know, it's a myth that if you just drink a whole bunch of orange juice, it'll do anything for you.
I never had that.
No, but I'm saying, there's a point where drinking more orange juice doesn't do anything. Because your body can only absorb so much vitamin C in a day. So like, I think it's like, I don't know, but it's like 2 glasses of orange juice, and then if you drink more than 2 glasses in a day, you just pee it out.
Ew.
I think it's true.
Everybody pees.
Alright. Oh, he used the word pee. Oh my goodness.
Ew.
What's your question?
It's a lot of yeah. Do you know what's in chicken noodle soup that makes it so good for curing cold?
Nothing.
Chicken. It's your mama's love.
I'm pretty sure nothing. It just feels good on your throat.
Because it's warm.
Yeah, it's just because it's warm. I don't think there's any special remedy
Oh, it has.
other than mama's love. Yes.
Mama's
I could have used some mama's love the last couple days. Alright. So, quickly review. It's been like a week. There are 3 types of bonds. Raise your hand if you know one of the 3 types of bonds. Whatever, one.
Covalent.
Shane, another.
Ionic.
And last one. Okay? Alright, raise your hand if you know how to identify one of the 3 types of bonds. Derek.
Covalent is between 2 non-metals.
Yep.
Ionic is between a metal and a non-metal.
Yep. Okay? Alright, raise your hand if you know what goes on with the electrons during each of those bonds. Everett, give me one.
One gives and one takes.
Can you tell me which one gives and which one takes? Okay, because metals have low electronegativity values and non-metals have high. I mean, you guys remember them a lot. I'm actually quite impressed. Okay, give me another one.
Covalent, they both share.
Okay? And last one is
Metallic.
communal sharing. Okay, it's like the hot potato being passed because no one wants, but they need. Right? Okay. And not last chapter, the first half of the chapter, the first half chapter test that we dealt with was primarily focusing on what? On what? Covalent. Okay? We did Lewis structures, which was showing how guys share on each of those bonds represented 2 shared electrons, correct? Okay? This second half of the chapter is going to be primarily ionic, but there will probably also be some metallic stuff that we'll deal with at the end of this chapter as well. Okay? So, if we're going to do ionic, we should probably talk about ions once again. Boy, I feel like we have just hammered ions. So if I ever come to you and ask you what an ion is and you can't answer it, I will think I'm a failure as a teacher. So please don't do that. I don't want to think of myself as a failure as a teacher. So an ion is really just a charged atom, because we know atoms normally aren't charged. Normally atoms are neutral. They have the same number of protons and electrons. But if you take an electron, or if you take an electron or remove an electron, that's going to create a charged atom. And can you take or remove protons? No. What would that do? Yeah, very good, Stephen. It would change the identity. Now, I don't want to say that it can't happen, because you can do that, but it's not easily done. That would be a nuclear change, and that would be very difficult to do. And you should remember there are 2 types of ions, anions and cations. Can anybody tell me the difference between an anion and a cation? Or maybe just what an anion is, and then I'll ask somebody else what a cation is. Moira, can you tell me what an anion is? Or how an anion is formed? Maybe I should say that.
Anion is an atom that gained electrons, thus having a negative charge.
I'm I'm pretty sure that's on the next slide, so you won't have to write this in. Now, why does gaining electrons make it negative? Doesn't gaining stuff, doesn't usually become positive when you gain something, Steven? Oh, so if you gain negative things. Okay. All right. Cation, someone else. Yeah, objects or things that tend to have low electronegativity values are going to be the ones that are going to act like cations. Yes. Okay, so let me ask you, do metals typically act like anions or cations? Why do metals typically act like cations? Because they easily give up their electrons. They easily do because they have low electronegativity values, and therefore the nonmetals are typically going to act like the anions. Because they want electrons, and if they want electrons, they're going to become the negatively charged guys because they're going to gain the electrons. All right. Don't worry, this won't all be reviewed. We'll get to some stuff that's different. Wednesday? Man, feels like a Monday to me. I guess that's the one bright side of being deathly sick. Short week. Let's be honest, you guys were glad I wasn't here, weren't you?
Well, let's just say you were here, we were just glad you didn't have class.
Yeah, I like you.
Sure.
I also didn't class, why would I do
That
so?
we had, that you weren't here, so just saying.
I mean,
I didn't cheer,
you
I
guys
was
just
like,
the other class.
I was sad, okay? I actually like this class.
But thanks to you being sick, I did get my Hobbit book done, so.
I got it halfway
Last
done.
period.
So you were a little thankful. So it was to your benefit that I felt as awful as I did. Thanks, guys.
You're welcome. No, thank you.
Actually,
Oh, I must have just got my second win because I was feeling awful a second ago. I don't feel so bad.
See, look,
We're
we
with
made you
you.
feel better.
Kind of. My ear really hurts. All the
ear
time.
infection.
Oh.
So, whatever I had, you know when you get the flu or you get like a really high, like a high fever, you know how you get like really achy? Okay, well, over the weekend, over break, there were 2 different days where I played ultimate frisbee with my family, and then also another day I played racquetball with a friend. And so I was outrageously sore when I got achy. I was like, how does that muscle hurt? Like, why does my shoulder all over my shoulder? Why does it hurt everywhere? I was like, oh, probably from racquetball. Like, I wouldn't have noticed it had I not gotten sick. I was like, why does every muscle in my back hurt? Oh, probably because I was playing frisbee and diving on the ground all the time. Man, don't get old, guys. It's not good.
I wish we will try our best.
You wish you, what?
I wish I wouldn't get old.
Oh.
Yeah, I really want to stay
I remember when I was you guys' age, I was like, yeah, that's not a thing. Getting old's not really a thing. Like, you guys are all just making it up. You're not really like, you don't
Getting
really
old's
feel
for
old. I was like,
Getting old's over.
now I know. Getting old is not fun. Due to fallen sin nature.
That's me.
Okay, so I know all this is a review. That's why I'm kind of breezing through this. But you guys already stated that when an atom gains an electron, it becomes an anion because you're gaining negatively charged particles. So what do you think's next?
Cation.
Okay, this will be it for review. Just get this in. I want to make sure that if for some reason you have a brain fart right before the test, you can look at your notes and be like, oh yeah, that's what an anion is.
Wait, is it a dog ion? I can't remember.
Doggone ion? I always thought it's cations. Cations are positive because cats have paws.
Cats
Or you
are.
could say, I don't like cats. It's the opposite of that, so it can't be. It's not negative.
Or
It's
you
positive.
just somehow memorize it. Just...
That is.
That's pretty boring.
I'm sorry that I'm like that. Because I just remember it.
But cats aren't positive animals, so
Sometimes they are.
yeah, kick them.
No.
Do you have cats?
No, I don't, but I wish I did.
I'm allergic to cats. I had a cat.
I wish I had a pet.
I had
My
a cat
cat
for
was
3 days
so
and then my dad
scared.
got rid of
I have
him.
like 5 cats.
Find
I'm
the
okay
frog.
with kittens,
Bring it
but
inside.
My brother.
I had a cat once.
And so
it
I
was
had a
terrible.
It's fun to spray
I like
water in
cats.
Throw them up in the air as high as you can.
Everywhere.
Watch them land on their feet. That's
Would
cool.
you stop?
So weird. Get up and put it on the ceiling.
Grab it by its tail, fling it up in the air. That's
My dad
awesome.
says he loves to eat cats, and then he goes, when they're on the side of the road dead.
Ooh. Yeah. When I see a
You're
cat go across the road, I swerve to try to hit it.
My grandpa shot a cat.
Speaking of
That's
cats,
what my
my
dad.
I once shot a demon cat before.
A demon cat?
I was with my cousin. I was with my cousin, and this cat was just acting. Yeah, this cat was just acting weird. Like it had the look, like it was like red-eyed, and it was like Satan inside a cat. I'm not joking. And there was something messed up with this cat. So my cousin brought out his I don't know what it was. I think it was his 22. You know that should kill a cat, right?
Yeah, I can kill a cat.
So he brought out his 22 and he shot the cat. The cat jumped, I'm not joking, like 10 feet in the air. And started running crazy all over the place. He had to shoot the cat 9 times.
What?
Nine lives.
No, but like, I mean, like, I think 6 of the 9 shots were in the head and the cat was still like jumping and running and freaking out. Like, I don't understand why he's freaking out, but like, wouldn't one shot to the head kill you? I don't understand how you need to get shot 6 times in the head.
They said those pellets are deadly little somethings.
Yeah, I mean, 22 shells, you know. I mean, that should kill a cat, right? I don't know, this cat, I mean, like, it must have had like 9 demons in it, and every shot killed 1 demon. But like, I'm serious, it
Holy
was,
water.
like, I thought it was gonna kill us. It was the scariest thing ever. Oh, also, when I was younger, I was a paper boy. Yeah, I was a paper boy.
Wow.
Yes, I was a paper boy. And there was this one house, and whenever I'd go put the paper in the door, and there was this cat that would come up to the window. It was just like, every time it scared me because I deliver in the morning some mornings, and I would slowly try to sneak the paper in without it hearing, and every time it would come and just like literally ram its head into the window. Bam! And we just were like, I mean, literally they had like a scowl. Like I didn't think cats could scowl.
I mean, some can.
I mean, if I had a 22, it probably would have taken 12 shots to kill this guy.
Oh, stop under exaggerating.
And I'm serious. Like I've never seen a demon dog. I don't like dogs either. But
How dare you?
sorry.
They're my favorite.
The only reason I don't like dogs is because it's just because I go against culture. Because culture loves dogs and they hate unborn babies.
Do you like
So-
do you like baseball?
I just have a problem with how much people love their animals but can't stand their children.
Ah.
So
Well, you could have.
Well, yeah, we can go with
On Monday night.
I was really sick.
Yeah, when we had we were going to leave and they had another gym that was like being under construction. And I just like looked in the window of the door to see what was in there. There was a cat sitting on like just some wood. And I was like, Mom, there's a cat in there. And it comes to the door and it starts like meowing like it wants out. So we told the like
Demon cat! Demon cat!
So we told the janitor.
Run!
Like, oh my goodness. Danger. It was so
Demon
weird.
cat, don't put this in. Okay, I just want to go over this. Okay? Says, can more than one electron be transferred in a bond? And the answer is yes. Okay, most metals can lose 1 or 2 electrons. Do we talk about oxidation numbers in this class? I feel like we haven't.
What?
No, probably haven't. We talked about valence electrons, right?
Yeah.
And we've talked about how this group has how many?
1.
2, right? And to become stable, what does it have to do? Lose 2. Okay? Or gain 6. It's not going to gain 6, it's going to lose 2. Okay, so can it lose more than 1?
Yeah.
Yes, things can lose more than 1. Okay? Wow, that was a complete mishap of
Top-notch
animation.
animation.
That electron should have went there.
Can you just go back?
I don't know why
Let's
that
watch
was
that
there.
again.
Oh boy.
Let's
That
do
was,
it instantly.
that was a faulty animation. That's not cool. What the heck? What the heck? I'm sorry guys, that was really disappointing. I'll have to fix
That was
it.
amazing.
That's
And
like
the answer, can they
top
share
notch.
2 electrons?
No.
No, they can't.
Okay, don't put this in either.
Okay.
Okay, can more than 2 atoms bond ionically? The answer is yes. It will bond with how many atoms it needs to make both stable. And I'll show you what I mean as we progress here. Okay? So here's the meat of what we're going to do here. Not this. Oh, let's see if my animation didn't get here. Okay, first of all, do you see how many valence electrons does magnesium have?
2.
2. Right? That agrees with what group it's in, correct?
Yes.
Okay? And fluorine has 7. Okay, so magnesium needs to get rid of 2 to be stable. But fluorine can only gain 1 to be stable. Do you see why I need a second fluorine?
Yes.
Let's see.
Oh,
Oh, yes!
Oh, that got you work.
I'll be here all week.
Because you work except you have this.
Okay, now let's try the opposite way. Now, sodium has 1 valence electron each. Okay? Sulfur has 6, so it needs 2, and that's why I need a second sodium for sulfur to be stable. And let's wait. Let's actually do a problem here. Okay? So here's what I'm going to have you guys do. Okay? First of all, why is this ionic?
Because lithium is metal.
It's a metal and non-metal, right? Okay? Now we're not going to do Lewis structures because they're not sharing, right? So we're going to do something a little bit differently. More different.
Something
More
else.
differently?
No, something else.
We learned this.
Okay.
We're so
Don't you guys learn this stuff? See, I never learned this
You
stuff.
can't have like the.
Okay, anyways.
Yeah,
Okay, we're going to show how lithium and fluorine bond to form an ionic bond. And I'm going to show you exactly what I want you to do. First thing you're going to do, you want to take notes of this here, guys. Okay? You're going to start by doing the electron dot notation of both.
Just,
I'm going to get rid of the access. Okay?
Probably this one.
I made the dot in the eye.
Yeah, pencil is probably going to be your best option. It's not as important as it would be in your Lewis structures because you're not going to have to worry about shared electrons or anything like that. But, okay?
You did it too.
You did the dot in the eye with the electron.
No, I just got rid of the I so it didn't confuse you.
Oh. Oh no, it's just irritating.
Okay? Now, the first thing you need to do is assess whether or not you need more than one of a particular atom. Okay? And here's what I mean by this. So lithium has 1 valence electron that it wants to give, and fluorine only needs 1 to be stable. So do I need multiple lithiums or multiple fluorines for these guys to be stable? No. Okay? So if that's the case, all we need to do is leave it like this. Okay? So here's what I want you to do to show how these bonds form. First of all, we said in ionic bonds, what happens with their electrons?
gives.
One gives, one takes. So we're going to show that with an arrow. Okay? So it's a kind of a before and after little thing here. So I'm going to have like an arrow that just means like next or produces, if that's what you want to look at it as. Okay? And then if the lithium gives an electron, it's going to become an ion, right?
Yes.
What kind of ion? A cation, because it's going to be positively charged. So here's what I want you to do. Anytime we do ions, we put them in brackets. And I'm going to put its charge in the top right corner like an exponent. Following? Okay? I'm going to do the same thing with the other guy. Fluorine is going to be my anion, correct? It gained an electron, so it's going to become what for a charge? Okay, now it only gained one, so it only is going to be 1 minus. Now here's what's different. I am going to show the full octet around lithium, or not lithium, fluorine. So I do want you to show the full octet around the anion. Now, lithium has a full octet, doesn't it, as well?
Yeah.
Yeah, right? If it drops the energy level, it still will have a full energy level. However, lithium is going to have a full energy level with 2, but we're not worried about that. Okay? So here's what you will need to do for each of these guys. Okay, here's the process. Show the metal giving electrons to the non-metal, and then show the charges of each of the two once you have given and you have taken. Okay, now if lithium were to have given 2, it would have a 2 plus charge. If lithium were to have given 3, it would have a 3 plus charge, and so forth. Does that make sense? Okay, and we'll see as we get to some of these more difficult ones if we need more than one. This one isn't an overly difficult one, so why don't you guys try to do this one on your own right now. This one's very similar, so I don't think you'll have too much difficulty with this one if you follow the process of what we did on the previous one. When you got her done, raise your hand. Yep. Yep. Nope. There you go. Yep. Yep. Not too bad, is it?
No.
No. Now, pretty much done. Yep. You almost done? You get it done? Yeah?
Well, I have a different because I thought you had brushes.
The only thing you did wrong is you didn't put the electrons around the bromine. You didn't put the arrow. Okay? So, now I'm just going to write the ending product here. What is it that holds these, how are these bonded together? Is it chlorine?
Rover.
Yeah, I mean, it's ionic. What?
He was in the middle of the yard, he tried to say bromine, and then bromine.
Bromine? Okay. So, okay, there's no dash. What's holding these guys together? What? Yes, the charges. Right? You've got a positive charge and a negative charge. What do those do to each other? They attract each other. Like a magnet, a matter of magnet holding these two guys together. It's similar. It's not exactly the same, but it's similar. What?
The way you say magnet, sorry.
Magnet? Sorry. Fine, make fun of me as you would. Alright. Let's go through this one. I'll do this one with you. Okay, calcium, how many valence electrons?
2.
Fluorine, how many valence electrons? So we show, uh-oh,
You know,
we need another chlorine,
oh no.
right?
Who?
Does that make sense? We need another chlorine because calcium is not stable currently, is it?
No.
No, just put another one below it or above it, doesn't really matter. Okay, but you do need to show with arrows where these electrons go. Okay? Same process then, your little produces arrow. Now we have to think here at what these guys are going to do. Okay? Remember, positives attract negatives, so you want to keep the negatives away from each other. Does that make sense? Because negatives do what to each other? They repel. Okay? So I'm going to have to probably put the positive one in the middle and the two negatives on the outside, right?
Yeah.
Okay? So let's put the positive in the middle. Which one is the positive one?
Calcium.
Calcium. Okay, what is its charge?
Positive. Yeah, positive. You got negative. Wait, you got rid of it.
Oh,
You
yeah.
got rid of its electrons on the side.
I haven't heard the answer yet.
It's positive 2.
Yes.
There.
Why is it a 2 plus
Because it got
charge?
rid of 2 electrons.
Yes, that is important.
Yes, you
You
do.
hear me, Moira? Are you sure?
Yes.
Okay, and I'm going to put my chlorines on opposite sides because I know chlorines are going to repel each other, but they're going to be attracted to the calcium. Now, is the chlorine 2 minus?
No, it's only 1.
It's only 1 minus. Each chlorine only gained 1, but since I have 2 chlorines, that's what makes it overall neutral.
This one. Can you write the 2 plus with 2 plus signs?
No,
No.
no. Don't confuse me, please. Okay? So what this is saying is eventually we're going to get to a point where we will actually write the formula of this guy. And this is what the formula would look like.
CaCl.
2 chlorine, 1 calcium. Okay, there is a faster way of doing this than writing all this out. And I will show you that when we get to chapter 19. We're at 18 right now, aren't we?
Yeah.
Okay?
Is that a real chemical?
Yep, that's calcium chloride.
What does it do?
That's actually what they throw out on the sidewalks when it's got ice on
Oh,
Like
Max
salsa?
exam.
it. Yeah. It's better than table salt or taking like NaCl and throwing it out because of a few things, which you'll learn in chemistry.
Doesn't sea salt kill weeds?
I don't know. Maybe.
My mom did that. She just not
All right, last one. I want you guys to try to do this challenging one.
What is halogen?
Oh, it's ALF.
Alan Fincham. See if you guys can do this guy.
Oh, there it is. AL.
Okay, so we had to add another. Okay, so you know how you had to add another chlorine?
Uh-huh.
Can you put it off to like the side, or does it have to be above?
I don't think it matters. I'm not sure what you're asking for sure, but
Since you have to add another one, can you put it over here?
I would just put it below. It's just gonna be hard to put an arrow to something behind.
Okay.
Does that make sense?
Yeah.
I mean, you could put them down here too, or whatever, as long as it's easy to see. I just want to make sure that you guys can identify what the charge is of these guys. Good? Yep. Good job, Ethan. Help me out by putting an arrow between those next time. Between your beginning part and your ending part, right? Otherwise, it's just looking like a bunch of. Yep. Now you guys are figuring it out. Good job.
Yes.
That'll do. I don't know why they do this, but they don't do +3, they do 3+. They always put the number in front of the chart. It's kind of goofy. Yes, sir. Make sure you kind of separate that with an arrow, though. Not a huge deal. Same with you. Make sure you kind of separate your beginning part or ending part with an arrow, like we did here. It just makes it a little bit smoother. Yeah, separate flooring is an FL. It's just F. I think I see most of you guys. Yeah, I wouldn't put these two negative guys next to each other. I have to put it here or here. Okay, so I'm seeing most of you guys did a pretty good job. So say we got aluminum here. And we needed 3 floorings. You guys all figured that out, which is good. And you guys all showed where the electrons go. Real nice. Now, a lot of you just forgot to put the arrow. It's not a huge deal. It just helps me separate, beginning and ending so I can kind of see it clear. Okay? And a lot of you did a pretty good job of keeping the negatives as far away from each other as possible. However, you could have done a little bit better. And here's how. Remember, we're talking 2 dimensions here. And most of you put it here, here, and here. Well, you would have 180 degrees between these ones, but only 90 between those. So it probably would be best, what is it, chlorine or fluorine? You just got lazy.
Yep.
Like here.
It's a fidget spinner.
Scientific fidget spinner.
Now, am I going to dock you for this? No. But it's good to think here that all of these angles are about equivalent. You see what I'm saying when I say, if you just put it here, here, and here, then you got 90, 90, and 180. Here you got like 120 degrees each. Worksheet.
Can I get with that worksheet, please?
Oh, did I forget a negative?
Yeah.
There
Oh
it
my
is.
god, the trimmer fails on that. It just blew up.
So can somebody show Sid how this works? I don't think she'll have too hard time catching up on it. But. Oh, I'm not giving you this. This makes no sense. You don't want this one.
Yay! Yeah, I was looking at it, I was like,
You don't want this one.
I wrote my name.
Maybe I'll do that eventually. Sorry guys. That would have been real difficult for you guys to do.
Oh, Rose already did it.
Oh. Yep.
What is H2O4? H2.
Okay.
Drinking.
H4 is for drinking.
The only reason I have an issue with it is because you after the first one I showed you, you get in trouble a little bit. So. And normally you don't. So.
What's CO3?
I kind of just had a blank out.
Carbonate?
H3O.